start.
Assalamu alaikum everyone. I am Aliza Irfan along with Khadija Kashif. So we'll be presenting on our project on optimizing FMCG distribution for Younas and Associates. It is a logistic firm which is operating in KPK. Our main focus is improving route planning, load allocation, and delivery time through data-driven methods. So let me give you an overview of Younas and Associates. So Younas and Associates is based in Peshawar and it has been providing logistics solutions for over 4 decades now with long-standing partnerships, including a 19-year collaboration with Nestle, which is a very important and big firm in Pakistan. So the company is now aiming to grow into a full 3PL service provider. So our the vision and mission of this project is like we want to revolutionize their distribution network by improving efficiency and reliability. We aim to enhance vehicle utilization, create optimized delivery schedules, and reduce travel routes and time using data-driven insights. So, of course, with like every other company, they are facing some challenges. So, the key challenges we identified are inefficient route planning, suboptimal daily load distribution, and long delivery times. So, our project is focused on solving these through optimization techniques. So, the approach we are following to solve these challenges are like we used Excel solver to design an optimized model by feeding in distance and time data. We allocated daily demand efficiently across towns. So we considered some key constraints like a vehicle capacity and delivery requirements to generate routes that minimize total travel time and distance. So the next some of the slides will be covered by Khadija Kashif. Over to you, Khadija.
Thank you. So, starting with our model, we are going to use the vehicle routing planning VRP using exact methods, for which we have designed the distance matrix, which includes Peshawar as DC and the other towns as nodes. The distances in this distance matrix are made considered two-way trips, as Younas and Associates only makes two-way trips, and during our interview we decided that the model will be run considering two-way data. So then we have made the XIJ table, which will show us the routes, the optimized routes, the FIJ table, which incorporates daily demand. Now, when we interviewed the Younas and Associates, they told us that their load allocation should be done considering daily demand, as that's how they operate, and that we were not able to aggregate demand into weekly or monthly demands. So, moving on in our linking constraints, we allocated the capacity, this is our allocated capacity considering the vehicles data that was provided to us by the company. And we used two vehicles with 17-ton capacity and 14 with 10-ton capacity, which reduced our vehicles from 31 to 16. Moving on, as my group member told you about the reduction of time, factors, we made the time matrix, which also incorporates the factor of two-way trips. So all the time between each node is a factor of two, considering the time of going from Peshawar and then coming back. Similar is the scene with this table of XIJs, which will show us the routes for the time matrix, the FIJs, which will show us the flow of the demand for each node, and the linking constraint table, which again has the same capacity as the distance matrix. To have both of our tables be optimized simultaneously, first we made these two cells, which have the sum product of the distance matrix and the Xij table, so that we are able to connect the Xij and the Dij table. And then to connect the distance matrix and the time matrix, we made a single cell incorporating both of these, so that when we run the Excel solver, the routes that are given in the Xij table of both matrices are the same. So when we ran the Excel solver, we were able to form 7 routes. Originally, Younas and Associate, the data Younas and Associates shared with us showed that they had 12 routes, and now we are able to bring it to 7. So this is our model, which incorporates the factor of daily demand, incorporates the factor of two-way trips of distance, incorporates the factor of the two-way distance times that is being utilized by them. And this model, what's the benefit of it is that they can change the daily demands, and the model will run them solution for how much capacity they will be optimal for them according to that demand. So not only does it not take a lot of time, because in Solver we are able to, add the constraint of time that the model should be run in 150 seconds. In this model, we ran it on 150 seconds, but it also is malleable and they can shift it according to however they want. So for sharing the results with us, I would like my groupmate to continue. She can share her slides with us and then we can continue with the results portion.
Okay, thank you so much, Khadija, for explaining the model so well. Let me just change the slides real quick. Okay, so moving on to the results. Oh, okay, so first is for routes. So initially, US and Associates, they were operated like 12 separate routes, like they were using 12 separate routes. So our using this model, we reduced this number to just 7. Like overall, they will just use 7 routes rather than 12, covering all the towns more efficiently while meeting their demand, of course. So the next is our time reduction, because obviously it was another important constraint. So previously their deliveries, it took them 1 to 2 days per town, but now by using these routes, like optimized routes, they will cover multiple towns and it will be completed in just like 1 to 1.5 days rather than 2 days. Okay, so the other one is their fleet optimization. I hope you can see the slide. Can you?
Yes, we're able to see the
Yeah,
slide.
okay. Okay, so this one is like fleet optimization. So the original fleet included 31 trucks,
Lisa, can you shift
but
back to the previous slide? I can
oh,
thank you.
sorry. Yeah,
Yeah,
okay. Okay, sorry.
perfect.
The original fleet, it included 31 trucks. Our analysis show that the same demand can be fulfilled using only 16 trucks. Because obviously, if I can like get what I want by using only 16 trucks, I don't need to use all the 31 trucks, right? So they will use these 16 trucks, in which the two will carry 17 ton and the 14 other will carry will be like 10-ton vehicles, so cutting excess capacity while maintaining the performance. So I think, yeah, that's all. Thank you so much, everyone.
Thank you so much.